Welcome to Unity 6 course, part 10. In this chapter, I will cover the physics and collisions in Unity. Actually, the collisions and physics cover character movement, generate collisions between the environment entities, and so on. You can access to all chapters and the other parts from the playlist here, and also the link is in the description. Here I need to introduce something. Here if I select one of the objects in the scene, as you can see we have a box collider here on the mesh. Actually, this is the collision component, which it can prevent from other objects to go through it, go inside this object, and actually this is a physical object. Now, if I remove this, as you can see, a green border has been removed. Here, a green preview of the collider, and here we can go to the physics tab, and we can access to many colliders and physics stuffs. For example, box collider, capsule collider, character controller, which is useful to implement the character movement logic for FPS character, first-person character, third-person character, and so on. It is a cloth for cloth simulation and so on, and the most important colliders are mesh collider, box, capsule, sphere collider, and these are the main colliders in the Unity, and I will cover them. And the next important section is the rigid body. Rigid body actually simulates the bouncing, the physics and bouncing and gravity for a specific object, and it's heavy to compute actually, and it's better to use it in some specific cases, for example for the character, for important objects in the scene, and for the rest of the objects in the environment just a collider is useful. I'll explain about all of them soon. First, let's start with the colliders. If I select the box collider, it will shape based on the mesh shape. And as you can see, these green borders represent the box collider. And if I remove it and scale the object in the x-axis and add another box collider, as you can see, it's shaped just like the mesh shape, the mesh main shape. If I add another collider, physics, and if I add a sphere collider, for example, as you can see, it's not shaped as the object shape because it's not a sphere object, and we can say it's intelligent, and it will recognize the shape of the model. I will upload every chapter of the course every week, so make sure to subscribe to the channel and turn on the notification to know about the new chapters and new tutorials. So the best shape for this 3D object is box collider. Actually, we have another collider. It's mesh collider. It will shape completely based on the object, no matter it's a cube, sphere, a cylinder, or a face, a human face, and that's a complex object. And if we choose a mesh collider for a face or a creature model, it will shape based on the vertices on the mesh. Here we can select mesh collider, and here we have some options. The first one is the convex. If we check it, here we have a collision based on the model or mesh structure. Now it has physics, and other objects can collide with this cube, and no matter which shape we have. If we go to the game object, 3D object, and sphere, as you can see, based on these green lines, it has a sphere collider. And now we can remove it and go to the physics and add a mesh collider and press convex. As you can see, it's a complex collider and it will shape based on the 3D object shape. I will talk about this trigger, provide contacts and other subjects. Actually, they are not related to this video. In this video I will talk about the physics basics. Let's remove the component and talk about the other colliders, box collider. Here we have this trigger, provide contacts, material. As I said, I'll explain them later, but we have the edit collider, which we can edit the collider, make it bigger or smaller using these points. As you can see, we are increasing the range of the collider. And the mesh collider, we didn't have it because the mesh collider is kind of complex and intelligent. It doesn't have any specific basic shape and it doesn't offer these points. Alright, here with the center field we have three subfields X, Y, and Z. It is the position of the collider, and here we can change the X, Y, and Z. If you put the collider here and another object, if moved toward this object, it will collide here, not here, because the main collider is placed here and the object is a preview of the shape, not, it doesn't have any physics by default. Alright, the next field is the size. We can increase the X, Y, and Z easily. At the center it is different from edit collider. Here we can change, it's not symmetrically. Actually, if we change this point, the opposite point doesn't change, but with the size we have this capability. Alright, the next collider is the sphere collider, and it is similar to box collider in a way. We have the edit collider here. We can change the points. Here we have the center. We can change the position, radius. We don't have size here, and it is the important sections of sphere collider. The next collider is capsule collider. It looks like a capsule, but if you want to see the complete shape of this collider, you can add a capsule object here. As you can see, we have a capsule collider, just look like the capsule shape. And here we can change the attributes of it. Here we have the edit collider, we can change it, and as you can see now it's look like a capsule. The next is the center, as you can see. The next is radius and height. We can change the direction as well. The direction now is the Y axis. We can change it to Z axis. Here if we increase the height, as you can see, it's along the Z axis, X axis, and Y axis. Actually, Y axis is useful for humanoid characters because it does look like a human body. Alright, let's add a box collider, and the next let's add a sphere collider for this, and next a rigid body. I want to explain about the gravity, the collisions, and so on. If you had two colliders and make a collision, for example this sphere with box collider, we don't have see any effect, any collision effect. And in this scenario we need a rigid body. Rigid body actually simulates the physics, gravity, and collisions. And at least one of your objects should have rigid body to see the physics simulation. Add a rigid body. and I will explain about the properties. Let's play the game and see the effect. You need to play the game first. Alright, as you can see, we have the gravity and the sphere falls down. If we move it manually in the scene view, as you can see, we have a collision and actually a pressure on the sphere, and sphere couldn't go inside the cube because of the box collider, and it has a physics simulation. And as you can see, we have a force and a pressure on the sphere, and a collision has been applied. Let's select the global transformation, and here, as you can see, we have this effect, and here, alright, as you can see, it's stopped. And the scene view, we can do funny stuff, and we can control the sphere. For instance, as you can see, this sphere can't go inside the cube, but if we add a pressure, and as you can see, it goes inside the cube. But in the game view, if we do it with the controlling keys, for example W, S, and A, D for your character won't go inside the objects. Don't worry about it. But in the scene view, we can do many stuffs, and it is a testing mode actually. As you can see, we have the gravity, the physics, pressure, force, and so on. We can do this works inside the code. Alright, before starting the physics in C#, let's introduce the most important parts and the most important attributes of the rigid body. Alright, let's start with the mass. Mass actually is how heavy the object is. If I set it to 10 or 20, means we have a heavy object. And actually, it's harder to push or stop. If an object with a value of 1 collide with an object with a value of 20, actually the heavy one will barely move. The next one is linear damping. Linear damping is air resistance for movement. So, in a simple word, with this value, lower linear damping value, if you slide your object, in this case the sphere, on ice, it goes far. But if you set it to a high value, it stops quickly, just like moving on a grassy surface. And the next is angular damping, or air resistance for spinning or rotation. This is look like the linear damping, but it applies on rotating. The next is automatic center of mass. When we check this option, we'll find the balancing point of the object automatically. Actually, consider the best point where the object can be balanced, and it's a very important aspect for applying physics. And the automatic tensor is related to the automatic center in a way. And automatic tensor means how easy it is to spin it around different axes, like a pencil. Consider a pencil, the center of it, and if we want to spin the pencil, we can easily spin it from the center, and it's easier to spin, and actually the pencil position still remain, but the rotation is changing and is spinning around itself. Actually, automatic tensor will find the best point automatically. The next one is use gravity. It's obvious what it is. Actually, we saw it in the scene, and we have a gravity effect on the objects. The next is kinematic, and in a simple word makes the object ignore physics forces. And if we want to move the object ourselves in code or animation and so on without considering the physics rules, we can activate this, and we can move the object using the keyboard keys and so on, but still collision remains for the object, and our object actually doesn't deactivate the rigid body completely. It has a collision detection. The next is interpolate. If we want a smoother effect for our object, for example, we're moving the object using the W key, and when we release the W key, and if we put it on none, it will stop quickly. But interpolate and extrapolate, I will explain about them and different. They will stop the object smoothly. The next is collision detection, and we have the continuous dynamic, and speculative. Discrete will apply the collision detection every frame, and it is not good for sensitive stuff. For instance, character movement, which our character can collide with walls, objects, and so on every time. And checking the collision every frame is not enough. And our object can pass through the wall if we apply more pressure or more force, and it is not good. So we need to activate one of these continues. I will explain about them in future. And continues is CPU heavy, but it will apply more collision consideration and more checks every second for an object. But consider to use these three options in some specific cases, for instance for a character. The next is constraints, and we can lock the object in three axes, lock the position of the object, or lock the rotation. If we activate the X and Y, this object won't move, and physics doesn't affect on the X and Y positions. I don't want to cover the layer for now and for this video. So in the next step, let's work with the rigid body in the code. Here in the code, we need to use the rigid body class. Here, let's create a serialized field, private rigid body. We have rigid body 2D for 2D games, but as our project is 3D, we need to use rigid body, and rigid body with lowercase r is the best name for this kind of variables. I will explain about the naming and the naming rules in a different video. Here, if we write the rigid body and dot, we can access to many methods and properties. We can see some familiar properties, for example, center of mass, collision detection mode, angular velocity, automatic center of mass, and so on. And you can change every attribute of the rigid body from the code. For example, you can check the surface, and if it was a grassy surface, you can change the linear damping to a higher value to lower the sliding effect on the object. If it was ice surface, you can make it lower to apply a higher value of sliding. We have access to some methods, for example, add explosion force. If we want to implement a grenade effect or everything that has explosion, you can use this method to apply explosion effect. And you need to specify a force with a float value, explosion position, you need to pass a position of the explosion effect, and so on to apply the explosion effect on the objects in the scene. The next is add force. I want to cover this completely in this video. Actually, explosion force is not very important for this video, and add force is more important. Here in the add force, we can pass a force as vector tree. For example, if we pass this value, it will add a force with a value of 1 for the x and y and z are 0. So we don't have any force in these two axes. And we can add any force we want. And we have 4 variations of the add force here. The first one receives a force, just a vector tree. For the second variation, we have force mode. For the third variation, we can ignore passing a vector tree and we can pass x, y, z separately. And the fourth way is to passing the x, y, z separately and force mode. So what is a force mode? Force mode is an enum. I will explain about enum, naming rules, and some kind of advanced features of the C# in the future videos, but I will give you some options that you can choose between. Actually, the force mode is the type of force to apply, as you can see. A regular force, the acceleration, which starts fast and it will slow down, velocity change, impulse, and so on. I will explain about them later and we will use them based on our requirements. I don't want to cover all of them. But the default is force, the regular force. Here let's save and try. Right, here we need to drag and drop the simple code, and here we have a rigid body field. We need to drag and drop the sphere and it will detect the rigid body and put it inside the rigid body field. Here let's play the game and you can see a force. Alright, as you can see we have a force, a value of 1 for the x-axis, and it falls down. Alright, we can do it with keyboard input just like the object movement. Here instead of 1 we can get the input, get axis and horizontal. The horizontal is A and D. A and D. Horizontal. And for the Z, which is this axis, we can get the vertical. And let's see how we can control the sphere using the keyboard keys. Right, in the game I press W and as you can see we have an object movement, but it's different. And here if I release W key, as you can see our object is moving because it has physics applied on it. And it is hard to control actually, and we need to adjust its attributes, the rigid body attributes. For example, we can increase the linear damping, and here let's try. And if I move the object, it's hard to move, but it stops quickly. Alright, these are the basics of the rigid body, but I want to say something. For the final spec, we have a way to get the components using codes, and you can ignore here dragging and dropping the object itself in a field. We have the rigid body here. It's not necessary to drag and drop the object here. We can use and we need to use this process in awake or start. Let's do it in start. We worked with awake a lot. We can fill the rigid body with a method, a specific method get component. Get component will get a specific component with a type you specify inside these two signs, and we need to get the rigid body. We need to type a specific class, a class we want to get from the current game object, and call the method. We will get the rigid body component attached to the current game object. Alright, set it to none, and we don't have any rigid body, and C. As you can see, the rigid body has been filled out and we have this sphere here. Alright, we already know about physics and rigid body. In the next section, I will explain about the character controller here. Character controller, which is better for applying the character movement, character rotation, and so on. It has many features related to the characters, and it's very useful for every character, no matter it's humanoid character or a creature.